are 6 through 10, and my goal with this first packet is that maybe you're getting about half of them right. I don't know that we've talked a whole lot about scoring, we will later, but usually about half right on the multiple choice is a level 3. We want to get past that out, like, eventually, but right in that zone right now is just fine. So this guy is a rate in people per minute, and we're trying to use a trapezoidal approximation to get the number of people. And again, people per minute times minutes does give you people. It's said to estimate using trapezoids. You really don't want to graph that, but if you did, and I'm not going to graph it like right, but it looks like it's kind of going up or whatever, you kind of made a fake graph. Remember with the trapezoids, it's all about just remembering how to get the area of a trapezoid and then how to work the table so you don't have to graph it, correct? So I'm supposed to do the trapezoid, and the formula for a trapezoid is 1/2 of its height times what? Left plus right is what I kind of try to remember. It helps me on the table. The height is the distance between the two parallel lines, so it's actually going to be your change in time, right? So if you remembered that, it's easy. If you didn't remember it, this is one that could easily come back. So those are all of the heights of my trapezoids, right? So if I were to set that up, I'd say, well, I have to do 1/2 of the first height times left plus right. And then I'd have to do 1/2 of the second height. You guys can help me with the arithmetic. Times its left plus its right. And then I have to do 1/2 of the third height times its left plus its right. Somebody who remembered how to do that and did their arithmetic by hand and got a number, tell me what it is. 185? Awesome, thank you. I don't want to waste your time doing arithmetic, but that one was almost like kind of just purely do you remember, because that skill we were good at, but like I said, there's lots of review we need to do. This is the doozy. And here's why. If I were to start to do it, first thing I need to do is figure out what those graphs look like. That's not actually too difficult, but I bet a lot of you neglected something with this one, so I'm going to talk about 6x squared minus 9x's graph first. What is it? It's a parabola. It opens up. If you find the zeros, it makes it the easiest thing to do. So I'm going to do 3x times 2x minus 3 equals 0, so I can get my zeros. So right here at 0, and then let's say 1, 2, so at 1.5. Okay, those are the zeros, correct? What else is kind of nice to get on your parabola? Because I don't have a calculator. Vertex, it's always right in the middle though, and I know it opens up, so I wouldn't waste any time actually finding it. It's in the middle of the two zeros. The next thing is y equals 3x, and this is where you have to be careful. Let me go change to blue. So y equals 3x is going to head right through like this, agreed? But be careful, because look what it says to integrate from. It says to integrate from 1 out to 4. That's from here out to here. And what happens right here between the two? Top and bottom switch. The minute I start doing this, I'm going to come back. Do I know how to do it? Yes. But is it going to get messy? Yes. So this is one where I'd be like, I'm going to wait on this one. But what you actually should do is consider the area right in here. Whoopsie. Right in, what's it going? Right in, it's not allowing me to shade. So you need this area. So from one, oh, there we go. So from 1 until where they intersect. Who found where they intersected? Where was it? 2. Yeah. So you would actually need to integrate from 1 to 2 first. And it'd be kind of a mess, because you would do the top function, which is the line, minus the bottom function, which is the parabola. Not that we can't do it, it's just that's going to take a lot of time, correct? I have to make 2 integrals, though. Do you see why? Because what happens once I get past here? The top function becomes the parabola, correct? So from 2 to 4, now I have to do my parabola minus my line. And this is where I go, I'm coming back to it. I don't know the answer, and I'm not going to do it. It's arithmetic. Unless, did anyone get that far and do it correctly? Because my guess is we missed the fact that they swapped. Did you? What'd you get? Okay, we'll take it.
That's right.
Okay. Well, guessing's actually, there's something to that. All right, next one up, number 8. This is one where I always like, if you're stuck, draw a fake picture. I've got a function, it's a parabola, it opens up. That's what I know. There's my fake function. It says, if the line tangent to the graph at x equals -2. So I'll go over here just at a fake place. I've got a tangent line, it's hitting at -2 comma something, I don't know. It says that if that tangent line is, what does it say? Parallel to y equals 2x plus 3. What does that mean if it's parallel to it? Same slope. So the slope of this line is equal to what? 2. Okay? It says, what's the value of k? All right? So tell me, what do you think you're going to have to do with this to figure out what the value of k is? You're going to have to take your -2. Agreed? What are you going to plug it into?
F
So,
prime.
F, which one?
F prime.
Yes. Oh, I see what you're saying. Yes, so I'm going to take my 2. I was actually finding the point, but we can go that route too. So my function is the parabola x squared plus kx. I know that its derivative has to equal 2, correct? And it says I have to get the k value. So what am I going to plug in right here? Y. It's on both of them, correct? It's the tangent line. So I'd have 2 equals -4 plus k. Who's my k? Who got it? All right? Now again, they're getting a little trickier, right? This next one's nice and easy if you kind of know what this graph looks like, and it should. It's y equals x. Well, that's about as nice of a graph as you can have. And then once you hit 0, it's y equals 2. So again, sketch stuff. It does help. And this just means find the what? Area, correct? And my area is going to be from -4 to 0, a triangle, right? And then from 0 to 2, it's actually a square. Agreed? So this is just a geometric one. If you're like, how do I integrate it? They didn't tell me what it is. It's right here. So I would just do this one with area. This would be a 2 by 2, correct? 4. And then this one would be base times height. What's the height on this one? -4 as well, correct? And then what do I do with it? Cut it in half. What
Wouldn't the height be 2?
Oh, 2, yeah. And then cut it in half. How much? What's the answer?
How do you get a triangle?
Did I do it wrong?
It would be 4 for the height.
What did I do wrong? I've got y equals 2. I'm going from 0 to 2, and it's up at 2, so that's 4. This is from -4 to 0, so that's 4. And it'd be at the point -4, -4, correct? Oh, I didn't make it negative. Damn, that's my fault. It is a 4 by 4. Half of it is 8, but it's actually a what? Negative. I was not seeing a 12 up there. I'm like, what the hell? So that one's done. It would be a nice -4. And then our last one, number 10, is making sure that even though some of you can avoid U-sub by back substituting, they're making sure you know the process. So really it's nice because they tell you what to let U be. Agreed? So if we go through our U-sub process, what's the first thing we do once we determine our U? We do our du and we change our limits. Whichever one. I like to change the limits first. So I put a 1 in. First, I'd be at -1, and then if I put a 3 in, I'd be at -5. Correct? So this is out, no limit change, no limit change. Between the other two, how do you decide which one it is? Du. Yeah, your du would be -2. Now this is way easier than how you were tested on these. I never told you what you use, right? So, but they're just testing that you know the process of U-sub. So it'd be a -1/2 fraction. I put how many wrong you got out of those 5 at the bottom. You got 3 wrong, 2 wrong. Hopefully not all of them wrong, but there's time. All right, so that's done. The next thing, take out your taking yes.
If it's a negative 1 half part fraction, but when you put in the limits, doesn't it swap the sign? So you have to flip for
No, because they didn't
Sorry,
swap
I
them.
didn't
But
see that.
watch for that. Yeah, it's a good question because if the limits were swapped, I would need a positive 1/2, and that's actually not outside of the realm of possibility. So you're going to go into your notes, and your notes for this chapter, I apologize, they're in the process of being redone. So they're kind of a hybrid of old and new is what you got in there. So you've got some stuff we're never going to touch. I want you to go to, you should have in there where it says March 9th, 2022, and it says topic separation of variables. Do you guys have that in your packet? Yeah, what page number is it? There's no page number on it? Okay, so we're going to be in here. We already did yesterday how to separate, and we actually did this exact one. So you're going to go to this guy. We are going to talk about how you find particular solutions to differential equations. I think I'm only going to do 2 with you, and then I'm going to do 2 really slow instead of 4 kind of fast. All right? And then we'll see how it goes. We'll probably need another day on it on Monday, because sometimes people struggle with this. So, right here, I've got a differential equation. It says find a particular solution. So here's my answer being started right here. Okay? Yesterday it said find a general solution. What that means is Carl was in there, and so there were an infinite actually number of answers. We had a C. Today we're going to say you have to go through a specific point. All right? Did you guys find it?
It's for the
Got it? Okay. So they're a mess. Next year they'll be great, but they're kind of just a hodgepodge. All right. So I need to force mine when I put in an x into my y function. A 0, a 5 has to come out. That's going to help me find Carl. So my answer is y equals something, I don't know. When I put in a 0, a 5 has to come out. We start the same way we did yesterday, though. If you were absent yesterday, you're going to be a little lost. But we separate these variables like this. And that we practiced yesterday, right? After we separated, what did we do, guys? We integrated. We're really careful with our antiderivatives. I would even check them. What's the antiderivative on the left? All right. Absolute value matters. And I said yesterday, be really careful because that's not natural log y squared, correct? This would be y to the -2. You'd add 1 to the power, divide by that power. But that one is truly natural log. Over on this side, I get x squared over 2 plus what? Now I'm going to tell you something. When you're finding Carl, you can do it any time after you integrate. When can you do it? Anytime. Some people say, I'm going to find it right away. Some people always wait till the end. Some teachers teach you do it right away or wait till the end. I do it personally when it feels good to me. Like, I don't like the natural log in there, so I'm not going to do it right now. You know what I mean? But you could, and I'll show you how it works out the same. The thing is once you find him, he goes in, and he goes through all the math manipulation on out to the end. All right? So I am not going to find it right now. I'll show you what happens if I did. But for me, I'm like, this is still a little complicated. I'm just going to let him kind of hang out there, and I'm going to go attack the y. How do I do that from yesterday? Yeah, I exponentiate. So nice and slow from yesterday. And I do e to the x squared over 2 plus c. All right. The left-hand side is easy peasy because they were inverse operations, and that's why I chose to do it. Who remembers what I said to do on the right-hand side? Yeah.
make them like multiply together.
Yeah, we're going to say that that's actually e to the x squared over 2 times e to the c. So I'm going to write every step today since I'm only going to do 2 of them. All right? That's what we do. Do you remember why we do that? Because e to any constant is a what? It's a constant. So I usually will go like that. Sometimes they'll replace it with a k or a c sub 2. it's fine if you just want to kind of keep it as Carl the constant going all the way through. So this is what I have. C e to the x squared over 2. Alright? What did I say, Kate, you do with the absolute values? Anyway, what do I do with the absolute value bars? Yeah, you miss a ton. Yeah, you do plus or minus. But here's where, again, Carl's kind of like Gumby. He kind of gets morphed all the time. What's plus or minus any constant? Just a constant. So we usually will see this as C, and it'll wash out. If it's supposed to be negative, it'll wash out when I plug my point in. Okay? So this is called a general solution. This one we did yesterday. This one would be done, except this is the particular one that goes through the point 0 what? 5. So now what I have to do is replace my y and replace my x. What is my specific constant for this problem? 5. So my answer is y equals 5e to the x squared over 2. That is called a specific or particular solution. Okay, and I told you I'm only doing 2 because I'm going to show you something. I'm going to go back up to the top and you're just going to watch. Don't write anything down. So I told you you can find Carl the constant anytime after you've what? Integrated. Okay? So suppose I stopped right here and I said I'm going to find him right now. Okay? What would happen is I would plug in my 5 for y, and I'd have, just watch, I'd have natural log, absolute value of 5 would have to equal 0 squared over 2 plus c. What would my Carl be? Natural log of 5. Once I found him, though, what did I say you must do with him? Put him in, correct? So the minute you find him on this level, if you're going to do it at this, again, you can do it any time after you integrate. The minute he's in there, he stays in, and he goes through all the manipulation with it. If you have to double, you double him. If you square root, you square root him. Does that make sense? So right here, this would now be a natural log of 5. Correct? If Jordan found it right there, it's in, it's going through all this stuff. This would have been e to the natural log of 5, right? What is e to the natural log of 5? 5. Do you see how it fell out as being what we got at the end anyway? All right? So we're going to do one more that's a little more complicated, and if you just, I think that's all we'll do today. So I want you to go in. We're going to practice these on Monday too. Let's go try this number 3. And it's only one. And then you can either work with a partner. I was going to group you out, but you can do you when I pass out the worksheet. So this first one, I have to send my function y. Here's my answer. When I'm done, when I plug in a 1 and -4 better come out, I need to separate first. So let's go do that. We have y dy on the left, because I multiply both sides by y, would equal 1 plus x over x dx on the right. After you separate, you integrate, and you should show that you're integrating, by the way. I had a couple in my 4th hour that were just integrating without writing it down. You can integrate in your head, but you have to show that you're integrating, if that makes sense. All right. On the left, easy peasy antiderivative, y squared over 2. On the right, I need you to digest how you're going to deal with that, because you're going to be integrating twice in every problem, and we have lots of techniques for that. And we have trig, and we have power rule, and we have u sub. How do I handle that? Yeah. Yeah, I can break it apart. I look at u sub first, and if this was an x squared, no, that still wouldn't work. But right here, I'm going to break it apart. You are correct. I'm going to take that common denominator, and I'm going to break it up into the 2 pieces like this. It's totally true that 1 plus x over x is 1 over x plus x over x. Okay, so next up, I still can't find Carl because I haven't integrated yet, correct? What's the antiderivative of 1 over x. Natural log. Right? So we get lots of those in here. What's the antiderivative of x over x? Dx. Yeah, it's just x. Now what do I do? Plus c. Could you go find it right now? Yes. But I'm not going to. Because, I don't know, this is just kind of complicated in that I'd have to double him and square root, and he'd have to go with everything. So for me, I'm like, yeah. But I'm going to show you what happens, because I told you I'm doing too slow. So draw an arrow over there, but I'm not going to go that way. I'm going to keep going with this problem. I'm going to inverse operation and get rid of the 2. Y squared equals twice natural log absolute value of x plus twice x plus what? Yes. Now, had I found it here, understand I would have actually, if I found it here, I think it ends up being a 7. And what would it turn into? 14. It has to, once it's in, it's got all the math has to go with it. All right. Next step, I think I'm just going to keep going. My y is going to equal plus or minus. We'll decide which one now because it's a specific solution. It can't be 2 things. It can only be 1. So if it were 2, I'm going to write this down. So I waited to the end. I often do just because I get in the flow of things, to be honest, but sometimes I stop right in the middle. I rarely find it right away. That's just me. Right here. Now I have to figure out what C is. How do I do that? I take my original x and my y and I plug them in, and I forgot what they are. So my x is 1 and y is coming out. So 1, negative 4 is what I need to use down there. So back down here, 1, negative 4 is going in. So I'm going to write that over here. 1, negative 4. So I'm going to indent. I usually do. I'm going to go negative 4. Has to equal plus or minus the square root of 2 natural log 1 plus 2 times 1 plus c. That's kind of what I have to make sure happens with my curve. All right? So what is natural log of 1? 0. So I have negative 4 has to equal plus or minus the square root of 2 plus c. What am I going to do next? Square both sides. So 16 is going to have to equal 2 plus my c. What's my c? 14. So 14 is equal to my c. I'm going to outdent and go back to, there's a lot of work to show, but I don't, you guys seem like you're getting it. All right, so I'm going to go back over here and leave the plus or minus on, because I have to tell you how you decide which one. But I'm going to go and write my answer. 2 natural log absolute value of x plus twice x plus, and I got a 14. Agreed? If it were me, I would maybe double check this and put in a 1 and go, okay, 0, 16, square root of 16 is 4. It is working, correct? But how do you think I decide whether I do the positive or the negative? Anyone want to guess? Yeah, Chris.
Your y in the given is negative. So
Yes, you go back to what I call the initial condition. It says your function needs to spit out a negative 4. Agreed? So I will get a 16 out of here when I put in a 1, but I want it to spit out the, you see how I decide which one it is, right? I go back to the initial condition. All right, before I give you your homework, because we are going to, that wasn't very much for notes. I said over here, I just want you to watch because it's the trickiest thing, finding Carl in different places. I told you you could find it here, correct? What would I have plugged in for my y? Negative 4. I would have squared it. I would divide by 2 and I would have an 8. Natural log of 1 plus 1 plus c. This is 0. What would my c have been? 7. The minute it went in, at this step I doubled. What would it have become? 14. What did we get? 14. You see how it doesn't matter where you find it. All right, great. So homework-wise, I'm going to pass this out. You can work with somebody on your own, but I want us all to do the first one because it's kind of an FRQ on your own. And then you have 20 minutes, 25 minutes, 33, I think. All right. So this packet has some generals and some specifics. You got to read it careful. Here you go. There we go. So what I want you guys to do is do the first one right now. It's a very typical FRQ type question. Usually, like, it's the last one. It's often a DiffyQ. I got a slow field, an old question, and then what we just talked about, a particular solution. Let's see if we can ace it. The slow field's the easiest and the most frustrating part. Making it. If you're absent and watching the video, I have a copy of their worksheet attached to the slide, so you'll just have to do it on a separate sheet. So the very last one is what we did today. Can I steal that? It was, the DiffyQ was dy dx equal 2x over y. And what point did we have to go through? 2, 1 or 1, 2?
2, 1.
2, 1? Okay, perfect. So your separation, I mean, this one couldn't be any easier, to be honest, but like the two we just did were a lot harder. Then you should show your integrating. You can do that in one step, so you don't need it, but you do need to show that integration. So we'd have y squared over 2 equals x squared plus c. Did anyone find Carl right there? Nobody did? You could have. I personally like to just double. I kind of get in the flow. So 2x squared just plus some c. Did anyone find it right there? No? You're all waiting until the end? That sounds good. So my y is going to equal plus or minus to be determined 2x squared plus c. First thing, is it, how do I get the c? Plug 2 in for the x, correct? So that would be what, 8? I'm going to erase over here. So I have y equals plus or minus the square root of 2 times 2 squared plus c. And it's supposed to equal a 1, correct? So this would be 8. What's c have to be? -7. Yeah, so my y is going to equal plus or minus the square root of 2x squared minus 7. How many of you had that? If you didn't erase either the positive or the negative, you won't get the credit for that final point. How do you decide which one to keep? The original. Yeah, when I put in a 2, what's supposed to come out? Positive one. So the negative's going to go. How many had that correct? Awesome. So your assignment is the rest of it. Let me see if there's any that I don't want you to do. So the first 4 are yesterday's stuff. So I'd actually like you to start with number 5. You do that just to make sure you're practicing today's stuff. Looks like a couple. Oh, it's good. I'm not going to cross anything out. And just start with 1. You do you. Work away. We'll probably do some delta now on this stuff on Monday because it's an important stuff.
All the miles that separate disappear now.